Okay, so let us start. We're going to go through some of interesting things that's coming in the next release, which is ready, and also there are some components that they also will come. The week after week. I think the next 2 3 weeks we just keep adding new stuffs and make things more stable. And also. And you know that we are officially announced the Twitter account, the accounts for Crawl4AI, and I'm going to talk about it later today or tomorrow, or when I drop a video on X to explain the new version. And then I will appreciate you guys also follow the accounts and let everyone knows and join to that accounts, because that will be officially the place that we post all the changes and everything. And also I posted my own accounts and creating more contents toward that direction. The very important thing is about zero point 0.7 ish, all the versions coming within the zero point 0.7 is we are getting very close to reach the day that we always wanted to have this the version zero point 0.1. I mean the 1.0.0. So that's a very kind of close moment. And one very important components for me being that agentic behavior or a crawler agent within the library. And and it has been always kind of challenging my mind what is actually an agent. Because what I know, what I learned in university, in major textbooks, and all the definition of the agents does not align with whatever typically people call it agent these days. And I have seen in many different places that there are debates on what is agent. And technically, most of time, what people are calling it agent, when I dig into what they have done, it's basically calling large language model, passing some tools, and make it like a loop. It's the nature is just like that. I have in natural language a query. I pass through the language model. Language model has access to some tools. It chooses a tool, get the data, and get feedback against the language models. Repeat till find the answer. But then people do some creativity. For example, before going to this language model, they use another language model to create plan, and then they ask this language model to follow that plan. But if you have very strong language model that train to do multiple tasks. Basically, that one language model can do both. Can plan first, do the reasoning, and then use the planning and then pick up the tools. Because when you build language model, when you fine tune language model, this is where you decide how your language model want to work. For example, you may fit it with the data that in all these data is like that. It's start with some textual planning, and then the second part is JSON based on the planning. So imagine you curate and generate such data like hundred thousands of them, and then you fine tune any language model. That language model learn to plan, then go and make decisions based on the plan. And then when you apply that knowledge to your case, to whatever you do, you get one language model that will do the job of having two language models, one for planning, one for this. And now this is a debate between researchers and people working in the area. We should do like that or multiple version of them. But the point is this: I don't feel it like an agent in the way that I know. I'll talk about the meaning of the agent a bit later. But to be honest, when I look at when people combine such a Lego, combine different combination, one way or another way, I can see we can do it with one language model as well. If you really dig in a little bit, search about, I can see people create infographic agentic patterns, and I see impression is high in social media. It means that people want to know more about it. And then if you look at all those patterns, there are multiple patterns. Reflection is another one that when agents generate the answers before compose it, there's another language model we use, maybe stronger, maybe fine tune on reflection to look at the answer, is the answer is correct or not, and then again back if it's not correct. So this is just like the way the pipeline that you're building with these Legos. And at the end of the day, they are all just calling the language models. You are the one defining. And some people want to make it more less deterministic, non-deterministic. What they do, they make this loop, the decision making of the loop, to be probabilistic. If you think of this loop, think about a while loop. The condition is not deterministic. The condition is not like if we cross five steps, it stops. If we could extract five items from that website, it stops. They use another language model to look at the situation, decide we continue or not. So that's now a probabilistic loop. It's an iteration, a loop that you don't know when you're gonna stop. It may stop after three, so it stops whenever the criteria is satisfied. And how we measure the criteria is satisfied or not, we're using a language model. A language model that designed to give you yes, no, get the results and tell yes, no. So word yes has a probability. No is a token, has a probability. And that language model decide when the yes probability is higher and you get that one and then you get out of it. At the end of the day, it's just probability, but the type of the loop will be different. So these are just design structures, how we combine this language model together. And I when I started to work on Crawl4AI, it's still now. I could jump and do agentic approaches. But because I couldn't see something that I feel this is the direction that I have to invest, it took time till now. And in this release, we're going to have a few components. That these components are very important to create that sort of intelligence that I like. And that's what we're going to talk. That's we're going to go through them quickly, and then later you can go to documentation and play around with them. Perhaps for a few weeks we're going to face with some errors and bugs. You guys help and report, and then we'll fix it to reach to that kind of stability. But these components designed to fit uh, eventually the crawling agent for Crawl4AI. I think when we do that, it's the whole system is really ready to go for finally the version one, and it's just a matter of the stability of all these components. So we're going to talk about these components. Maybe we can spine up the slides. We prepared some slide to see. Okay, I have it here.
Yeah, yeah, I'm presenting that.
And today I was watching Grok 4 release, and seems interesting in terms of human last exam. It's a challenging benchmark. Right now, based on what they say, looks good, but let's see when people start to test it and try it.
Yeah, the slides are up on the call.
Oh, you do have that? Okay, so
Yeah,
so when you have it, I'll also play it here. So uh,
yeah, I
first
shared
of
you
all,
the
so
slide.
this is the agenda. So I start to talk about it here, and if you guys have any questions, just drop it. The first is we're gonna have two versions, which actually already we have. One is the one that you installed with the pip install Crawl4AI, and we're gonna have a nightly version. The nightly version, it it's basically identical to the next branch. There is whatever I work personally on it, and I push, it will be there. And I mean, when I add a feature, I may not bring it to a stable version. It may even die. I don't know. But I work with multiple things at the same time. I experiment a lot of things. And when I see they don't have any kind of bug and error, it's good for an alpha test. I'll just push it there. So in this way, you will get a very steady release for a stable version, hopefully every 2 weeks from the team. Arwin and team and all the Nasrin, they will do that. But my side, maybe every day or every 2 3 days, I push something in the nightly build. And nightly build has a lot of stuffs in it. It's stuff that we may not release, or we may keep it there or whatever, because it's more like a kind of the experimental version. So there are a lot of things, and this helped us to to work better. So this will be nightly, and then you will get the library name to it's just Crawl4AI dash nightly from the pip, and it comes with the multiple versions. Versioning is based on the date and the time, because it may happen in a day I push two versions. So It has a date and it has the hours, the version. But just Crawl4AI dash nightly, it considered the latest version. So that's what we're going to do from now on. It's already started. And now look at these components. A bunch of components are coming. These components all together, they give birth to the crawler agent. We start from the first one. I created for each one of this, we have documentation right now. We have one example or maybe more than example in a docs folder. And also I have created one Python script that overview zero point 0.7 and you can run it. It has some good code examples, and also the terminal output is nice. It helps you to try, and it commented well, so you can see, you can read, you can get some ideas about it. And look at the first elements, the link preview or link pick. This is something that it's super cool. You know, to think about it when you go to the Google Drive or you even open your Windows Explorer, File Explorer, or Finder, wherever you go, you have this capability to look at all the files thumbnail, right? And then you see the thumbnail. If this is what you wanted, then you double click and then you open the file. So basically, it's a perfect technique to not use a lot of RAMs and memories and see just a little bit of the file and then open it up. This has been always a part of computer science, even in file management systems, database systems. They always have a layer that taking a snapshot of the underneath layers, the next layers, which contains the entire of the file. And then from that, we decide which one you want it. It's perfect, it's good. And now imagine if you are crawling a root page basically, and it has, let's say, 100 other internal links, a lot of internal links or external links. It would be much better if you can pick to the content of those pages without crawling those pages. We're talking about the situation that you don't want blindly crawl entire of a domain. It's very important. It's getting more important to crawl like this. Crawl on demand. Expand your crawling as much as you can, rather than you just bring down the entire domain. There's a very important thing. When it comes to the area of the big data, one of the very important characteristics of today data is their validity. Immediately the data is expired. The data is just not fresh. Huge amount of the data these days, they can just survive within a few minutes, and that data is not important anymore. You can an obvious example is news or trends, or for example social media, that kind of stuff. This is a very common case. So we need an approach. We need to start to learn crawling for very fresh data. That is what we are talking about. When I want to do that, it's important because I have to save the time and energy. That's why link preview is here. Link preview help you to extract only the first few bytes of every page. So when you send a request to a web server, any website, any domain, it's a HTTP request. HTTP request, the header contains the head section, and then it start to load the body. That's how browser works. It's linear. It starts from the first line, second line, third, and this and this and that, and then the whole data come down. And that's why when we build a web application, and if I am loading a JavaScript, external JavaScript, if the JavaScript is heavy, if I put it on top of the page and I don't use it, that will reduce the loading time of the page. That's why if you move it down, you bring it to the very bottom. So in results, browser load the page, and then the page is there. You can see everything. Those heavy JavaScript run at the very bottom, and that's a perfect thing. Of course, these days there are a lot of techniques: asynchronous loadings, deferred loading, but the concept is link preview extract only the head and doesn't do anything anymore. It doesn't use even browser. It doesn't need Chromium. It uses simple HTTP. It's super fast. It's fantastic. It reduces the cost heavily. You don't definitely need all the links of that page. So in this case, you link your main source, your main links, you crawl the page, you get all the links, you can set the link preview, and you get a snapshot of their head. And typically head has keywords, descriptions, metadata, all those kind of things that people they put for their page to get the SEO informations. Enough information that later you can make a decision that if you want to go and dive into that links to crawl it or not. And that is the second component. After this, I'm going to talk adaptive crawling. We are introducing adaptive crawling. But first, we talk about this link preview. So, so then you're going to see it. And then also it let you to pass a query. When you pass a query, then when it find those links, it extract their head. It uses BM25 or embedding to measure the relevancy. And if the relevancy is lesser than some certain threshold, it dropped them. It means that those links are not important. And that's what we're going to do. So I will show the code that we have here. Okay, you guys can see?
Not yet.
Not yet. Ah,
Oh yeah. Now we are able to see. Yeah. It's
okay, now you can see, right?
yeah.
Okay, perfect. So this is called, what later you can find in the repository, Crawl4AI 070 showcase. The components that I'm talking about, you can find all of them here. You can run it separately or you can run it in interactive mode. You can run this code and dash dash interactive. It gives you a cute menu so you can pick up which one you want to run. So let's go through the link preview demo. And I try to put some sort of description so you can read it and help you to understand how it works, what it does. And and that's a very important thing. And when you do the link preview, so as I said, it extract the head section, and then it apply a scoring system. A scoring system is important. It's basically intrinsic. Intrinsic score is based on the link itself, the position of the links, the attributes of the links. This is something that we have in deep crawling. So it look at if this link looks good or not, if this link is properly canonical or the attributes. So it give you kind of a score for that. It help you to not get caught with irrelevant links that are not looks nice. And then number two is the contextual score. The contextual score is relevant to the query that is passed to the crawler to decide if a link is relevant or not. So it's about the similarity, semantical analysis. So you can pass a query and then give you. So we have two scores, and then the third is the combine of these two scores into one final score. And this is the way that it helps you to control it. And if I go down, you can see how it goes. So you're familiar, everybody, with the crawler run config, our main configuration objects that we use for start the crawling. And now this time we have this new field, link preview config. And then there are a bunch of parameters that you can set. You don't need always all of them, but of course, here I'm just bringing all here. First, you can say you can control on if you want only external, only internal, or both of them. Of course, it's funny if you set both of them false. And then also we have max links if you want to have a kind of cap on it's why max link is good because if you pass query and then you're getting top 10 for example links relevant to what you want because in knowledge retrieval in information retrieval depends on how much your query is technical or complex. You can make a decision. For example, if it's not that much complex, maybe 2 3 is enough for language model and then get it and then bring it out because it's so important. You know what? I was just tell you something here about why you have to be so sensitive about not come up with approaches that generate or consume lots of tokens. Of course, everybody here understand that you're going to pay at the end of the day for tokens, but it's not just because of that. Let's say tokens all are free. You are extremely limited with the context window. And context window is the bottleneck of transformer because transformer right now naturally to do the calculation is quadratic. It means that if you have 100 tokens To generate the next token, it needs 100 times 100 at least calculation, because that's how attention score works. A lot of efforts, better algorithms, cachings is around to make it more efficient, but still, that's the nature of the design of the transformer. So if you're really happy that, oh, my large language models support a million, you are not able to run that a million multiplied by a million unless you are just using some massive infrastructures like Google. And another thing is that when you are working on agentic softwares, it's so easy to suddenly reach to 600, 700,000 tokens, especially those bad design agentic pipeline that they keep use language model to think, to decide, think, and decide and generate and combine, and all these crazy design that people share, but they don't understand that that design means a lot of tokens. And easily you will reach to 600, 700, and for example, Anthropic is 200K, or even OpenAI new model go to the 1M, but it's not effective after 300, 400. They're not very effective. And open source models are not that big. So that's why I don't think it's a weakness of the model. It's how we think, how we design. It's very important that you think you don't need to crawl entire of the page, all the links. You have to really come up with good solutions to extract the information. And but let's keep this in the mind because we're going to back to this token usage a lot. Then we have this concurrency, and the concurrency means that when it's going to extract head and data from the pages, how many you want to do it at the same time. Here you can relax. You can put even 1,000 because it uses asynchronous, and it's fine, and it fetch all the head section. And as I said, it doesn't need Chrome browser, so it's a very efficient way to do that. By the way, again, let me choose the opportunity that, remember, many times for many major crawling you don't need Chromium. You can do with the HTTP, and you know that we do have that in Crawl4AI. We have playwright strategy, we have HTTP strategy, and very soon comes something very crazy that I think I may be able to show you today to you guys, that you can use your own Chrome to become your own Chromium, actually, with a kind of nice extension that we created. So this is the query finally, and this is the WordPress. And so here, when I pass all this kind of stuff, then the rest, these are not Crawl4AI code. These are just the rich library to make it looks nice, to make the demo looks nice. So basically, you can remove all of it. It's just a progress. That's it. And then you just run as usual. And here, for example, we're running over async IO, which is a subpage of Python. And I guess the query that we are passing here is, let me find the query up. Okay, look at this query. For example, we're interested on this page and all of its children links relevant to these keys: asynchronous, coroutines, tutorial, that kind of stuff. So I'm interested in such crawling. So now this is more different way of thinking. So when we do that, again, the crawl results, everything is like that. And then when you go to the head data, you know that we have always the head data that contains the metadata of every links. Then we have this total score. And then you can imprint the total scores and then filter or look or pick up the one that you want. You want maybe the top 10 or anything that you wanted, and finally print it. Again, these are just demo to make the demo beautiful. It's not a part of Crawl4AI. If you are not familiar with the rich library, don't get confused. Okay, this is just table is make in terminal to have nice table. And let me run this one, and then we get a little bit better understanding. Let me, okay. So look at here. I got all the links. I got the internal links, and then I'll just get those that they have a score, and I sort it reverse through, means from the highest to the lowest. And let's run it. Okay, I'll go to, okay, you see, if you go to the docs and then examples, here you can write Python. Okay, you can do it in interactive mode. Uh, I'll just route it today. So it might have some errors in things, you know, cannot import. Oh, okay. Mm, okay, I'll run it here. Can you see my also, let me see. Are you able to see my terminal, or you guys just see my VS Code, Arwin?
We are able to see both.
So you can see the terminal now?
Yeah.
Then why?
The terminal and like you're typing something like as in there's just like same terminal and VS Code both in the same window.
Okay, so
Yeah.
let me
Yeah.
do some.
Yeah.
No, I was talking about another terminal, not this one. Um, just let me see which virtual environment I have. Which Python? Okay, okay, I guess this is the one. Okay, if I go to now, watch example. Okay, so now let's go with link preview. So we're going to talk about this thing. So the first is that query that I mentioned to you guys. So what it does, it just extract a bunch of things. It started from this page, right? And then it started to extract internal links that matches, and then and it found this one. It found within this page there is another link. The text of the link is this: run Python coroutines. And you see the total score is high, is intrinsic in the contextual score, and the links that I have, the core that I have is relevant. And then when you get to the kind of things that are not relevant, it's really contextually. You see contextually become much lesser. So if I look at the contextual score, is more relevant. Runners and Python coroutines, actually that's what we are looking for coroutines tutorial. And this is just an example that it fetches internal URLs and pick up those that from this 32, the top two, these two are really relevant. This is very fun. And you don't need to go through all those kind of 32. You know, I checked it, and those 32 are really does not important, especially when we are talking about a question answering system. That we want to make sure that we create enough knowledge and then go answer the question. So this is very interesting. You know what? The link preview does not crawl these links. It just gets the head. But then later when we go to adaptive crawling actually crawl the content as well, which you will see. So there is one more demo here we have. Let me run the second demo, and you will see. This second demo is a very small research assistant. You see what it does? By the way, if you go to the library, to the GitHub repository, there is a very detailed research assistance created. I have it in a notebook collab. I think we talk about it another time. And here, what I'm doing is this. This is a very interesting example that you can see it here. Look at this. I I purposely I pick up this. I wanted to make sure it doesn't uh, joke us. This links scikit-learn.org stable does not have anything about tutorial. It doesn't have anything about a machine learning tutorial. And it went through everything, and I'll pick up all the links and look at all of them, score them, and all we see they are below the negative score, zero. And eventually found nothing because I wanted to make sure that really we have nothing, and even tested in multiple example. So this is again another example. The second demo show you that it's has this common sense to not really returns everything. So it's important. You don't go further. This is why you need such a kind of things, especially if your case study is about finding a query in terminal. And when we are talking about agentic, we need agent to understand this stuff because one very important thing, regardless of a decision, what is the definition of the agent? Is the agent must have a strong power of decision making. And decision making comes from such statistical metrics. I have to look at this, I have to measure things and then make decision. Otherwise, you just go blindly, just scroll everything and then extract your data. It may take more time, but it always gives you an answer. What you want to come up with a bit a smart solution, right? Imagine you just do this one, whatever. Don't care about what user asks. You just scroll entire of the domain. You eventually have the data and then pass it to a language model with a long context window and answer the question. This is just a kind of lazy way. You don't need agent, you don't need to think, you don't need to do anything. But apparently, it's not a good, proper way to do that. So this is an example to show you that you can also be safe to not get irrelevant leaps. The third demo is actually testing same query for different URLs and measure for you this scoring. It dig into the score. And I'm very fan of contextual score, but I think intrinsic score matters, especially if you are extracting from website that they care about their SEO or the structure matters for them, and the way that they structure the links. This is let me back again here. You can see the second demo. You see the second demo is here. I have again Crawl4AI config, and then I put a score threshold 0.3. It's a little bit, I bring it up. You can put 0.1 is a very normal low one, but you can play around with it. 0.3 is high. You know, this kind of similar in the realm of similarity, it means high. And then again, we have the third demo, which we just discussed, and the second configuration, which this time I'm considering the external links as well. And then we have the same core, no, not the same core, yeah, core, yeah, the one that I said, machine learning and tutorial. There's nothing over there. I even know about a page that even external links has nothing to do with the tutorial. And the finally was just some sample links that I told you to explain the concept of the scoring. Nothing happening there. It's just a demonstration of what a score means, what factors exist. If you are interested to know more about it. So this is link preview. If you have question right now about link preview, is fine. Bring it up before I go with adaptive learning, adaptive adaptive crawling, which uses link preview heavily. Any question? Please ask now. I'll before I go for adaptive crawling.
Uncle, you want to have Q&A after the full presentation or now itself? So there are folks who
Fine
are
with
waiting
both.
to speak.
Okay, so if you guys can, if you don't forget your questions, you write it down. It's fine. I'll continue, and then we'll keep it. It's for me both possible.
Alright, so Sela Dai, he's requested to speak. So Sela, I just promoted you to speak. Could you try asking your question? So he's asking what branch are you using for the docs? So this is next branch, Sela. So next
Yes,
is
the
the
next branch. This is going to be released uh, tonight or tomorrow to the version 0.7. So whatever is here will be in the 0.7 as well. Okay, so I go with adaptive crawling. Adaptive crawling has been something that I've really been excited about it since very beginning. It's heavily based on information theory concept.
Uncle
Uh,
Cody, there's just one question.
yes.
Like they're asking if it will replace the async URL seeder, the link preview.
Sorry. What?
So we have this async URL seeder, right? URL seeder. So there is a question if this link preview will replace the URL seeder.
If the link preview do is can I didn't get the question. Sorry, Arvin.
So we have a URL seeder, right? Like down in the demo 797. Yeah. So they're asking if like the link preview is a replacement of URL seeder.
Okay. No. But, talk about URL seeder. URL seeder is basically It give you whatever links exist under that domain. And it's not just like internal links of one particular crawling. It's not coming to the crawling. URL seeder is separated than the A-run function. And we can say link preview is subset of things that you can do with the URL seeder, but more specifically for crawling. And actually, it's a good question you guys ask. Uses the same part of the library, so it's not even the code is the same. I mean, they use the same functions for measuring similarity and that kind of things. URL seeder is when you want to broadcast and you want to get whatever exists in that website, regardless of the query, and it supports query as well. But this link preview is an ability within the A-run functions for that particular crawling that you do that, especially for deep crawlings or anything else you want to do that. It's for internal links. So crawl results, they have such information about their children, a peek of their internal links. But no, it's not a replacement at all. You're going to use them along with each other's. Anything else?
No, that's it.
Arvin, do you see anything?
No.
Okay, we go for adaptive crawling again. It's very interesting. As I said, it's based on information theory. It's so nice if you think about it. I give you a little bit of theory, just the background about it, because this is going to be very important in our agentic approach as well. It's about how much information do I need to answer your question. If I am a person, or if you are a person, imagine that you have to consume 10,000 calories for whatever knowledge that you gain. You're not going to be so generous. You try to be so efficient to not learn everything in your life, to just learn things that you need to do in action. Because you have to consume a lot of calories or you have to pay tax. Imagine tomorrow government come and add a new tax that based on how much you have to pay me. So you start to become efficient, like the way that we use or petrol or fuel or money or anything else. Adaptive information is like that. I know information looks like commodity because wherever you go, you can read them. But when it comes to building real application, it's so important to find enough information to answer the question. In information theory, there are a lot of techniques. There are many interesting techniques. One of the beautiful part of computer science is this information theory division. That there are a lot of things. For example, in decision tree classifier, decision tree is simply you've seen it. You can even intuitively feel it. It's like you go to a doctor and then you describe a sickness that you have, and the doctor starts to ask you a question. Have you, for example, swimming yesterday? Your answer is yes, no. Some of the questions are yes, no. Some of the questions are more than yes, no. But that doctor in her brain, by answering your questions, building a tree, following a decision tree to find out what is going on with you. And you love those doctors by one or two questions, they know what's wrong with you. But those very newbie doctor, they start from the first, second, third, fourth, they continue with 10 questions. So you can imagine in their mind after graduation, there is a huge tree. They learn, they memorize that tree, and then they ask you all the questions and move into this tree based on your answers. Eventually, they reach the bottom, which they can go more. And that is where they are certain about what is hidden in you. And they can react or they can do something. Decision tree is like this. Decision tree classifier, the job is you start from the root. As soon as possible, you want to reach to the level that certainty is high. When certainty is high, we have another nice term called from thermodynamics, entropy. The entropy is low when everything is certain. The entropy is high when uncertainty is high. You can think of in molecules and atoms in a hot matters. They shake, vibrate fast. You don't know where they are. If you take a picture, it's everywhere. That is when entropy is high. That is when uncertainty is high. That is when every answer has the chance. For example, if I tell you I drop a dice, and this is the basically maximum entropy happen when every outcome has the same chance. 1/6, 1/6, 1/6. Anything can happen. But if I tell you that, hey, the number is odd. Now it's not 1/6. Is now is we just half. Now we have 1/3 because you know that it's 3 or 5 or 1 or 3 or 5 is not 2, 4, 6 anymore. You see the entropy drop, uncertainty drop. Life is like that. When you're very uncertain, you feel maybe anxious. So anxious is a good measurement. Now we love those machine learning model or even those people that very soon they bring you to the level that uncertainty is high, is low, and entropy is low as well. So, so certainty high, entropy low. It was always like that. Adaptive learning or any adaptive approach is like that. How can I find the shortest path to the answer, to the goal, to whatever I am searching? And also at the same time, I consider how much I spend till to the point that I am. These are basically search algorithms, A star algorithms, and artificial intelligence heavily is search, finding the best way of answers or the path to the bottom of the tree. Adaptive crawling works like that. It's designed to get a root, a link, a URL, and think that how can I really crawl minimal in the way that generate maximal knowledge for query that you're asking me, and not only for that query, for similar queries in the area that you're asking. If someone come to you and ask you something about, for example, something that maybe everyone knows here is like, let's say the large language model, and then the first question is what means token. So if someone asks you this question, suddenly your brain get an understanding of the person. Person needs basic informations, and your brain is start to load your basic information. If you are a teacher, you go and search and read more about that basic level, examples, animations. You come back and then answer. If tomorrow the person question change, then you follow that one. So the knowledge you generate for that person reshape. And this is the concept of adaptive crawling, or basically adaptive knowledge construction. And the goal of the adaptive crawling is more building knowledge for information retrieval system. It's not daily crawling, industrial crawling. And again, you can see another components based on link preview, which I want to have it to be able to have a knowledgeable agent that can increase its knowledge based on your situation. You can imagine that you can build an application that for different group of your user base, not per user, doesn't need group of users, naive users, expert users, users interested in, for example, a sport, users interested in politics, users interested in graphics, start to crawl different things for them. And when they ask questions, answer the question back by itself automatically decide to crawl more information. It's not like someone asks him or asks it. Nobody. They just know they need more information. They have this capability to measure their knowledge relevancy, and when drop from a certain level, they crawl more, they add more. And it's beautiful because you don't need to start to do constantly 24 hours crawling. They do the crawling by themselves. And this is what we are doing now. Adaptive crawling is the birth for many more smart versions coming into this adaptive crawling area that I just started. So we go through it to get the sense of it, how it works, and then you will understand. So, okay, as usual, which I liked configuration object because it led me to put all the parameters in one box and then use them, and they're all becoming a little bit Crawl4AI style. We have a config, and then we make an object, and then we run it. So it's this is the structure. So let us start from the very in right now I have two strategies, but the strategies are going to be more and more. One is a statistical strategy. A statistical strategy does not use any things from transformers or embedding models or large language models. It's just based on perfect, a strong part of the natural language processing that's been around before language models for decades. And when I test, it works perfect. And so what I do is you can apply a lot of things. For example, let's say when you want to expand your knowledge, when you want to adaptively uh, um, do more based on query that you get, go with maximum 3 pages. That means if I ask you one questions and I give you a URL, you answer the questions, but you also go more, but not more than three. This can be fixed, this can be automatically, you can leave it, but here is just the meaning of after each question, how much your knowledge base increased. And you can save this into a vector database or in a SQLite, whatever is your approach. That's doesn't matter, is your opinion, how you want to do that. And we have a confidence threshold. The confidence threshold perhaps is the most important thing. This is that uncertainty level. If uncertainty is below zero point 0.7, this means that this adaptive crawler needs more information. There are many ways to set the threshold. One is just like this. That means empirical. You say, I think I want to put a zero point 0.7 based on trial and error. There are other ways. There are other ways that you don't need to set threshold. They just do it adaptively by themselves. They improve, they iterate till they think is good enough. And we have another strategy that does that. And some part of other kind of parameters that you can go to the documentation to see the real deal one. But two things important to me is the confidence threshold, and also the top K-links means that if I find a new page, because adaptive crawling is about crawling more pages. So think about it. You start with the page A, but they do more by themselves. They decide. And then when they go to each one of them, they look at the links again. So max pages talk about the total number of the pages. Top K links talk about how many links from each page. I really look at them. So top K links means pick up the best two top links and think about them. Digest them. See if they add something to your information, to your knowledge or not. And it's very smart. Is in a way that if reading a new page does not add that much knowledge, it drop it. So it must be a gain. Otherwise, it doesn't do anything. And that is what you see here. It's the mean gain threshold. It means 0.05. It means 5%. Means 5%. It means that if I don't get anything out of it, I leave it. At least 5% of my current knowledge should come to the game. That's why I learn it. It's intuitively, if you are doing something like that in your life, it should be similar. That means you read a book, if that book you know that adds something to you, and depends on your decisions. Maybe you are so hungry to learn more, or maybe you're so expert in something, and this mean gain threshold will change. If, for example, I'm expert in topic, my mean gain threshold is high. Otherwise, I don't open the book. So this is how adaptive crawling led you to dig in. But anyway, this is you have to explore, you have to play with numbers. It's really fun to build really smart application. Now we have this new term come to the game: adaptive crawlers. You create your async web crawler, and this time you have this adaptive crawler, and has a very important function: digest. It get the start URL, it get the query, is optional. Is the query means like what is the main things? It can be a user questions, it can be yourself. You can say that I'm interested in this and this and this and that. So you put the keywords matters to you. Remember, when you use statistical techniques are sensitive to keywords. They pay more attention to keywords. Embedding approaches, they look at semantic and relationship in the context. That's why we need both of them to get the best answer. Usually, we either do with embedding first and then apply re-ranking using BM25, or we start from the BM25 keywords, then we do reorder among them by embedding. So this is just the point. My point is that you need both of them to get the best. So anyway, this is a statistical, and then it just down when you digest, you will get very interesting statistical reports. You get the new confidence level. You can see what is the new confidence level. It increases. And then you can also see the crawl URLs. It return, if let me see if I have it here, is um, yeah. So it returns the crawl URLs for you. It has knowledge base. Look at the knowledge base. Knowledge base is nothing, just list of crawl results. Everybody should be familiar here with the crawl result, which is the main objects that come from the arun function. Now, knowledge is nothing, just collection of this crawl results. So nothing fancy. I just got a lot of crawl results. They have markdowns, they have informations, they have table, links, image, PDF, whatever. And I combine them all. And you know that when you use LLM extractions or JSON sys extractions, extracted data also is in them. So if you build a knowledge base of them and then you convert it, dump it to the JSON, you can give it to a language model. And that language model has entire of this knowledge. Or you can even decide which part you want. Maybe you don't want Markdown. Maybe you don't want the HTML, which I suggest you, if you have more, pick up either Markdown or the HTML part to reduce the size of the data that eventually you pass to the language model. So the knowledge base grows, expand or shrink I'll talk about the shrink as well. So the pending links is just refer to links that the adaptive crawler thinks they are good candidates, but for now we don't need to go there. So they are pending. They're still there. Later, use them and add them to the crawled URLs. And then we have the metrics, which metrics contains a lot of interesting statistical numbers. So I don't want to go through all these kind of things, but later you can go to the documentation, and I'm going to create a very long video about it. And I'm just waiting for 2 3 weeks to make sure all the bugs resolved. But it's perfect. It gives you very interesting. If anyone works on information retrieval or information matter, this should be the way of crawling. And I really want to invest on this. I think this is more important. I'm really understanding that it's you people and myself. We need digested crawled results more than just raw material. And I mean those with options. So I really want to invest more to bring more NLP for you guys. That Crawl4AI not only generate the raw material for whatever you're going to do that, but it comes with the capacity to apply a lot of natural language processing abilities. It can extract addresses, names, relationships, knowledge graphs. So you can imagine a lot of tools available. Then you can mix it, and then you save a time. You get the data, process data, and then you can use it directly with a nice shape into whatever you're building. This is, I guess, should be the direction. And there are two strategies: the statistical strategies and embedding strategies. So when you use embedding strategies, it has embedding data. You can save it in the vector database and do a lot of things. And there is a very interesting concept. I'll talk about it later. Semantic gaps. This is something I really love. It let the adaptive crawler knows where are gaps that need to fill. It's so good. It's just like what we expect from human to do that. That means you want to know what are the area that you need to improve. And why it's interesting to me because it's fun. It's fun to define mathematically which area you have to practice more. It's so really fun. Then we can discuss mathematically how much information this part of me doesn't need. So, and there's a geometrical presentations behind this, which I may talk in another video, that how geometrically I define this concept. So we'll be back to what we were doing, and I will run it later. So just gonna print the data, nothing. This is just printing the stuffs, and then um, yeah, here you just get all the pages and print it. So that's just all just printing. Now the second approach is let me go to embedding one. These are good examples. I suggest you trace it line by line and then see it. Um, okay, that's okay. There are, let me just, whenever you finish your job, you get the data. Besides you're getting the data, you can also have this helper function that give you the most relevant crawl results. So that's one way that you can get them back and then use it. But you can also go to the knowledge base and query all of them, and you take it out. And it's based on the statistic and the scoring model that you have used, either statistical or embedding. And I will show you soon the embedding approach as well. I'll go down, and you can also export the knowledge base. He has the export knowledge base. It just give you a JSON that including the whole things, and you can use it for any other applications that you want to use. But I suggest you always to do some pruning, remove some parts that you don't want it, or be clear about what you want. Okay, and this is the example of the and also you can import. This is very good. This is very good because the goal is this: you are saving the knowledge base for a users, for a category of the users, and then you can import and you can continue from that point. This is important. So you don't need to start over and over. This is a time consuming. So in this way, you have a growing knowledge base, crawl and grow and grow, and you can enable an ability that it kill or pruning. I call it pruning. That prune those branches that you haven't used it for a long time, or recency of them decline. So in this way, the knowledge base can shrink or can expand. Okay, so this is about adaptive crawling. Let me try. It's running just quickly. Um, I'll go for the two. Start to crawl the route, and then decide to go more. Is by itself? Oh, we got an error. Is subscribed. So I'll debug this because time doesn't allow me to go to the code now. It's supposed to finish and then give you the results. There's something wrong here in the demo code. This is about demo code, and then which seems here has been a mistake. Me just quickly. Okay, let me comment this line for now. Okay, so I started with one links. It changed it to the three, and then and found three more links and to expand the knowledge base. Uh, and the confidence level is 45. So this is where you can play around with it. You can ask to continue. You can continue. Just continue till hit 0.7 or 0.6. It depends on your case. Usually 0.6 is very good. More than 0.5 is really considered good. But it eventually was 0.3 and then increase reached the 0.45 and then it continues. So you can keep continue doing this. Or the second demo, uh, oh, again, we have another line like that. Okay, I think the links does not exist. Okay, you let me double check the code for this part of the demo, and then I will update it in the code base. So, but the concept is something really I'm interested about it because been in the job for quite a long time, and to give us this chance. You know what? If you go to docs folder here, okay, I created bunch of different examples for these examples are tested, they're all working. This is a demo code that I created today. So this code is a very good code. Compare embedding approach with the statistical approach. You can see the comparison. For example, when you use the statistical or when you use embedding and embedding config, you can say, for example, look at the embedding config. You can choose the model. For example, I'm using the embedding tree small from OpenAI, or use local one, or Hugging Face, or sentence transformer, whatever. You can use it and use the embedding, and then you can compare these two to see which one produce better quality. Especially mix of them is good. And there are a lot of things here. I'm explaining different possibility for configuration. So this is something that my team we should spend time to create more material, educational material. This is just a very beginning of it, and trust me, this is going to be very very interesting component, and then when you see the value in your business and applications. So I think we are hitting 1 hour, right, Arvin?
Yes, just 5 minutes over the
Yeah.
1 hour.
Okay, I will go through faster. Just you guys can run the code and let us know. uh, Look at the virtual. So I go with the virtual scrolling. The virtual scrolling is something that I wanted you guys asking many times. What means the virtual scrolling? There are these difficulties in scrolling that, for example, you go to a list, you have to scroll to the very bottom to get more items. We had that. But there are more complex situations. A situation like, for example, if you want to crawl Twitter or X, what they do, they use these techniques that they don't generate HTML elements for all the posts because page get heavy. For example, if there are million of posts, It's not like really the React or Vue.js or whatever JavaScript framework that they use. It doesn't render HTML elements for all those kind of 1,000 or 1 million data. What it does, they have fixed number of HTML elements. They calculate dynamically how many elements can be presented by average in your screen based on your screen height size. Let's say they calculate five. They add five before, five after. So they make 15 HTML elements. When you scroll, these 15 are fixed, data sliding through them. That's the technique. It's a perfect technique. It's been around for many years, especially when the user interface or the CPU were not that much good, but it still is there and is great. It's a buffering techniques. Now we support that. So to run it, again, you have here in the main folder, you have virtual scrolling example. It's a very good example. I hope when I moved it to this code base, is there's no bug for that. Uh, this is something bug with adaptive code. So let me run it again. I'll go with the virtual scrolling. Virtual scrolling. Okay. Just tell me if you do you see, guys? Do you see the my window or not? I mean, there's a Chromium just open up in my computer. Can you see that?
No, no, not yet.
Let me see how can I share the screen that you guys can see that one. If I share, uh, it shares application. And if I share the application, uh, what do you see now?
It's loading up. Yeah, the VS Code. I guess the full screen, maybe.
Can you see the terminal, everything else, or you just see the VS Code?
Um, I see the terminal too, like in the back.
Why I don't see it myself? If I see myself, then it's easy for me to, oh, okay, now I can see myself. But let me run it again, guys. You know, because the example is really nice. Let me run this. I don't know if it's coming or not.
Um, no. So if
I
you go
run
to
now
the
the tool. Oh no, it doesn't come. Because can I share this portion of a screen with Discord, or Discord is just push me to share the
yeah,
app,
you
the window. It
you
doesn't.
share the entire screen.
Okay, so let me see how can I do that. I will stop again, and I want to say entire screen. It entire screen. Uh, gaming custom, no screen resolution, frame rate, advanced. When I do the make selection, it doesn't do that. Maybe no, I don't. It is it says click. When I go to every window, select that particular window. It doesn't let me to share the entire desktop. You know, yeah. Okay. Well, when you run this, share all application windows. You can see the VS Code, right?
Yeah.
Okay, guys, when you run this, what it does, a Chromium pop-up. In that Chromium, there are different variety of a scroller. One is like Twitter, which the one that I said. The other one is like similar to grid structures, websites that they have a lot of images and they replace the images. And it capture all of them. It capture for you and tell you, for example, although there is only 15 HTML elements, but there was thousand of data, and it capture all those thousand. It's literally the only place, only library, as far as I know right now, I search that capture such a scroll and build the virtual scrollers. It bring the data and mimic rendering and get the data quickly and fast. So you see, look at the code here, captured 490 tweets, and it's super fast and it's really nice. But I can't shoot because this doesn't stream it. Look at the code, but at least we can look at the code perhaps. This is I'm launching a virtual web server to open up that HTML example, and those are not important. What matter here is this: to reach to um, okay. So look at the crawler. So you have the usual crawler run config. You have this virtual scroll config, and the virtual scroll config is like that. You pass usually you can do, or you can even do it without this. You can do it with this, it's more accurate. I pass the selector of the wrapper, the container that this scrolling is happening. If you don't do anything, it starts from the body and reaches to the level that is scrolling. But when you do that one, is much faster, more accurate. And I can put some numbers, how many data elements I like to get in one page. Let's say 25, 10. It's just, you can control it. And I say scroll by. There are different ways that you can scroll. Scroll by means container height. Means if this much of page is available, I scroll like this. I scroll like this. You can set pixel, how much you want to scroll like that. Or you can set item by item. So that's the choice. The good thing is that when you make it by height, the challenging part is this. When you scroll again, you go to the next page. There are overlaps. Some elements are already captured, and we have some other elements. But it has this capacity to remove all those duplications and give you perfect clean results at the end. And wait after a scroll, you can set some delay because you want to make sure data is loaded. So, and it's going to be in the game. In the game, you can put the time to make sure in the asynchronous way, even when it's so difficult to challenge to check that if the data is loaded or not, you have that gap. And then you pass it to this, and then the rest is the same. You just run and done. You just get all the data. Nothing will be different for you. You can do your extractions, you can do the markdown, you can do whatever you want. Because it combines all of them and give you one HTML as if it was supposed to be all in one page. You get the point? So it's give you a long, big HTML that has all the data in it. So that's how it works. And so I just speed up to save the time. And so the URL seeder, we talked about it a little bit in the previous meetings, but it's there. The one that gives you the capacity to just broadcast and get all possible URLs exist under a domain historically, now and before and whatever, and including the sitemap. So you have a screenshot of all of them. And they come also with the query BM25, so you can make a decision. So adaptive crawling is totally different. You got it. It uses sophisticated mathematical approaches to decide, to think if my knowledge is enough or not. It's just like a human. And then it go and pick it up. And it pick up till the confidence is there. But URL seeder is you decide what you want to do, that your own rules, your own customizations. And link preview is basically just for one crawling. One crawling let you to get the data of those things. Adaptive crawling uses link preview. URL seeder is a perfect technique that you want URLs. You want all these URLs, and later you make a decision about it. And we reached to something very important, which I think we're not going to have time to talk about it. The C4A script. So I leave it for our next talk. It's the new language we created, a robotic language we created to let you control automation of the crawling, and without necessarily knowing JavaScript or Python code. And what is very important about it is it it has a capacity to be converted to any code, to JavaScript, to C++, to Rust, to Go, to any language that you may use for automation for the web. And in our case, mostly JavaScript. For example, as you can see, the syntax is like this. Click on the button that submit. Click on the button that the class is submit. If this such a thing exists, then click this and that. You write your script, it transpile it, it gives you a JS code, and then you can pass it to your crawler run and then use it. If I go down, there is one example. I remember I put one example here. There are a lot of example here, many examples. That means if you go through it one by one, crawl it, you definitely get it. And Okay, look at here. I am creating a crawler run config, and there is C4A script, and also which is the script that you created. Also, you can use the JS code because then you can transpile it and you can do that. Anyway, I'll talk about it by next week because now it just make you confused. It's very interesting. We created a playground, a tutorial, so you can go through it, you can learn, you can practice. It's a one step for our agentic crawler agents, as I mentioned. Means, and I want to end up by what I said at the very beginning about what is my perspective about the agents. Unfortunately, I don't go through this because it's getting more than an hour already, and it's supposed to be 1 hour. So I back to the agentic crawl because that's our plan to add to the list before we end up the library for the version one. And as you know, some of you, I don't know, we are planning soon to launch a cloud version of Crawl4AI. So, and I'm very excited about that one as well. And when it comes to this agentic approach that I mentioned, our crawler agent, it acts extremely different than the typical agentic models that I have seen in this last 1 year. It's not about generating the data for you. It's not about building the app. It's about finding the solution. We use large language model to think. Imagine you ask me to join to your team, and then you tell me that you want to crawl something, and then you want me to think for you, and I will think. And what I do, I write the best version of code one can do with Crawl4AI. That's what I do for you, right? I write a very optimal, very good, very fast, efficient, as much as possible without need for the language model, written in the Crawl4AI. I tell you this is your code, run and have fun with it. This is what we want to do. We are building training a crawler agent that is sophisticated to generate Crawl4AI code. Then you run it for every million of times and as much as possible with less dependency on language models. Not like a typical these days that many applications that people are creating, they feed the HTML, the data to the language model chunk conversations, and language model decide what to do, generate JSON, they do this and do that. All these kind of things can be done with the pure Python code and using a language Crawl4AI library. So you will see soon a very interesting smart agent. You say what you want, it generates a Python code. It run that Python code for you, and it can do things that not any other agent can do. That you can come up with a crazy demand. You can even ask for some statistical analysis to be added to your data. You can do calculation. You can do things that can be done only by running a code, and this agent will do that one, and it makes sure to give you with low token consumption. And when I compared with other available solutions that they provide crawling agent, it's uncomparable in terms of the token usage. It's not even even I can't even compare, but it's there and you will use it, and it's really fun. So all these tools that I define, all these steps that we discuss, bring us to this converge to this point that can build that agentic. Already, I'm working on it, and I'm testing these days a lot, and to bring it out almost is done, and I guess I'm doing just final test to tell you. So you can imagine, you can envision that you give your text query and you can give some instructions, you can give some data, whatever. It really go and generate a beautiful Python code. It run it. If can't get the data, it modify the code, eventually answer the code. It's similar, somehow similar to how Cloudy Code find and do the coding and build the code, but in a different way by considering reduction in a number of the tokens. So everybody, this is just a glimpse of changes. There have been a lot of improvements. There's a big list. We will generate the list and in the release notes. But I pick up few components that I think are important because they are gateway to agentic model. I couldn't talk about our Chrome extension, which is a very interesting thing, and this Chrome extensions and C4A scripts allows you to automate. You can act on a website, and Chrome extension record it, and then it turn it to a C4A script, and then the agents mimic you. So it looks like you are training a robot. You will see. So you do activities. It look at you, it record, and then you don't need to even go through those details yourself with the language or JavaScript or anything else. It extracts quickly on the page within the Chrome all the data super fast, and we compare it is far more accurate than any other approaches that we test. And it's of course heavily based on this open source concept that you guys use it, giving feedbacks, and eventually evolve in the way that no other closed source can do that. So uh, that is also about extensions and other stuff. And also we have one more topic, which is what I propose in opposite of llm.txt, which is a kind of a contextual model protocol, and that's something else that we should talk. So I guess we leave these topics for our next meeting, and that's all. So please stay tuned because I'm going to release the notes soon, and you use the library. Give us feedback, please. All the bugs, bring them up, and within 2 3 weeks, I guess the version will be very solid. So I guess I just quickly wrap up at this point. Now, if for Q&A, I hope still people have the energy to ask question, and I will answer. So that's all, everybody. Arvin, back to you.
Yes, guys, like any questions, like just there is a symbol up top, like basically requesting to be a speaker. So if you guys are like drop it in the chat. So there are a couple of questions. So URL seeder, like Sehrik is asking URL seeder, like how to stop on active link instead of max links. So Sehrik, like I'm not sure what you mean by active link. Do you want to like maybe uh, come across like be a speaker? Like just let me invite you. Yeah, let's do that. Yeah. So you.
Hello, can you hear me?
Yeah, we can hear you.
Yeah, so basic when I last time tried URL setter, so what happens if I grab the max links, it gives me max links as expected, but problem is all these links are not active or head doesn't pass the head check or liveness check. So sometimes you want like only 100 links, but when you get the result, you see some of these links are also actually dead, especially when you get from common crawl index result. Uh, so in this scenario, if we can get something like, let's say, give me 100 active links, so that will be like more helpful because you actually never know when you can get 100 active links. You have to crawl until the end.
When you use the URL seeder, you can pass live test a Boolean flag. If the live test is true, it check if the link is broken or not. So then you can use that one to just make sure you get valid URLs. And to do that, it used a head request to make sure that these URLs exist, but it doesn't slow down the process. Uh, that is, I understand. That's why it has that flag for live tests. For live tests, you don't need to use head extraction. Live tests will do that.
But I think Anuruddh, his question is like we have this max links parameter, right? If you stop at that, so he wants those max links to be applied only for active links, is what I understand.
I can't hear you, Arwin.
Am I clear now?
There is, I guess there is. Okay, okay. Go on. Say it again.
Yeah, yeah. So what he means to ask is like right now we have this max links parameter, right? So if you reach the max links, it stops the URL seeder there. So he's saying like he wants to apply
Oh,
max links only for like active links. I want 100 active links instead of 100 links in which maybe like 25 is active.
makes sense. Makes sense. We can have this option that by max link, I mean max active link.
Yeah,
Understood.
something like that.
Yeah, well, nice.
And
Nice. Well, I
take
like
that
it.
down
Makes sense to
for
me. Yeah.
take that down us. Like we'll work on that
Yes, yeah, I love it.
in our next split.
Good.
So Anjali is asking, how can we evaluate crawl for AI scraped results? Um, yeah, could you expand a little bit more on that? Like, what do you mean by like evaluate results?
What is evaluate? Evaluate mean can have different meaning. But you give an example or something because then we make sure to give the related answer. A few search
Just
questions, and
typing.
I want to avoid. There's another one question while we are waiting for Anjali to explain. Regarding URL seeder, will it be able to handle multiple queries simultaneously if I have few search questions and I want to avoid scanning assignment? Oh yeah. Well, what you're going to do is this. You can send your search query and combine your search queries with the new line characters. Okay. So then it works. So new line characters, next line, next line, next line. It basically you can do that. But it's interesting because it remind me we didn't talk about it properly in the documentation out of it that
Yeah,
the which people can send multiple queries but as new line join with the new line.
got it.
But we can make it like a list of strings as well. Then we have okay like scrape results from Walmart website. How can I evaluate if the scrape results are right or if all products are scraped from the website? What percentage of products are missed out, and so on. I am still not sure got it properly, but I think when you extract the data, especially structured data, so you with LLM or without LLM, it doesn't matter. You can pass a schema to uh, a run function, and then the extractor makes sure the extracted data matches with that schema. In this way, you are 100% sure that in terms of the shape of the data is valid. It means the data has those fields that you wanted. If this is the validation evaluation that you are talking about in terms of the shape of the data, if we are talking about the existence of the data, if that's the case, so then every products or items has URL. Then you have to make sure that the URL exists by sending head request and make sure it's not 404. If this is what you mean, using a schema is the solution. If you mean by the links, if you use URL seeders or you use link preview, these links exist on the main page. They all get this live status that if they exist or not, the link is broken or not. So that's what you can do. It's before you start the crawling, so you can filter them out. I hope I could answer you. You know, if I got it right. What do you mean by? Uh,
I think she just so Anjali, like there is a hand icon next on the top right. So like if you just click on that, yeah, I've invited you to speak.
Hello, hi. So I have used this Crawl for AI to build automatic scraper, and I am getting the script results for any website. So it is able to handle all that. But how do I evaluate, like from Walmart, all the products are scraped or not? So let's say product. I'm not talking about product name. I have given product name reviews and so on. I'm not talking about if any columns are missed from the website. How do I compare if all the products which are there in the website are scraped or not?
if my understanding is correct, how if a page has 40 products, if I and I don't know how many has, how can I be sure that I really got all the 40 products?
Yeah,
Is that
exactly.
correct?
Yes, yes.
Okay. And then is if we are talking about a website that we know the count of the products, or we are talking about a scenario we don't know the count of products.
We don't know. So Walmart has a lot of products, so we don't know how many products. So then in that case, how do we evaluate the performance of the automated model?
Very interesting challenge. You know, question. You just got me thinking. Uh, okay, I let's think the worst scenario. Worst scenario is when there is no information about the total count of the products in a page, and there's no way also directly to know how many elements exist. Because if there is a way that I know how many elements exist, then it's easy. It's just I know how many I extracted. Okay, so I
Okay.
come up with few approaches. One approach, because we're talking about evaluation, is not something that you want to do all the time. You want to make sure your approach, how reliable is it, right? We want to measure it. Is this is not like you need to do it every time. Is that correct? My understanding. You came up with the code. You want to make sure, hey, my approach captured 98 percentage of all products. Let's say
Correct.
something like
Yes.
that.
Mhm.
Okay, so if that's the case, the best approach is a test data set. What I mean by that, you pick up some links, challenging links that you think is challenging from the Walmart, and then you pass the HTML, extracted data to large language models as a judge. And this time, a good large language models has the capability to compare this. You say, hey, this is the HTML. My scraper, my crawler extracted 20 items. Tell me, confirm exists 20 items or not. Because this is not the thing that you want to use in your production, it's okay. You're using it for the test evaluation. And then you selected 100 links, you run it, you statistically, you just calculate. At the end of the day, you know how many tests you passed, how many tests you didn't pass. So basically, it boiled down to a typical data scientist job to know how valid has been your measurement. Does that make sense?
Yes. 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 It makes sense.
And you do this one, and because and you know what, language models should to know this, no need to be a very strong language models. I mean, like Flash Gemini is good because it has a uh, long window context. The context window is long, so you can get it immediately, and then you define it in the way that language models reply back yes no. You force it to back yes no because it's a binary question. It tell you that yes or no, and then you really can get it out. And then those cases are no, then sit down and then research on them. Why no? Why what you missed or whatever. This is a very classic, strong approach for bringing up the accuracy.
Okay. Okay. Got it. Thank you so much.
You're welcome.
All right, guys. I think it's a
Thanks.
wrap.
I think it's
So before we
yeah, it's become
close
one
out,
and a half
just a
hour.
couple of things. Uh, so we are having